this either cosine or sine terms. So that is what we called as half range. We can, with that we call it as half range series. So now, if the function we wish to extend only cosine terms, it contains only cosine terms. So then this is called as cosine, that is half range cosine series. This we called as half range cosine series. If you wish to extend only contains sine terms, it contains only the sine terms, that is Fourier series. You want to extend only contains sine terms, it is called as half range sine series, half range sine series. So that is now why we wish to find this function, the question. So here it's simple. Given any function, suppose I wish to take in a straight line, a function f of x is equal to x defined in the interval x belongs to 0, 2. I have a function, it is defined 0, 2. So that is, we can have a straight line again in the xy axis with the 0, 0 origin and 2, 2 at the end points. So for this function, I can have a say it is a periodic function. So if it is a periodic function, okay, so it is a periodic function. Now I want to extend this with a even periodic extension. I want to extend this function over a full range. So that when I say full range, it has -2 to 2. So in the -2 to 2, I wish to extend, I can extend two ways. One is odd periodic extension or even periodic extension. So odd periodic means odd function or an even. In other words, I can extend this with an odd function or an even function. So that means if I wish to extend this as an odd function, so what the curve will reflect, so it reflects, it is symmetric about origin. If I wish to extend, it is an odd extension, that means odd periodic extension. So it should goes to again up to -2. Okay, this is odd periodic extension, or we call it as, so in the entire -2 to 2, f of x is now an odd function, not an even function. So this we called as odd extension, odd periodic extension. Okay. So now I wish to extend the same original function in the interval 0 to 2 and considering full range -2 to 2. Now I wish to extend even periodic extension. Even, that means even function. So when I say even, it has to symmetric about y-axis. So now that if I use even periodic extension, or I will come to that, what is that even periodic extension? So that means it looks like a even function. So it extends like this. Okay, so it is a straight line again. So this is, so now you see f of x looks like a even function in the interval -2 to 2. So this way of extending symmetric about y-axis is even periodic extension. Even periodic extension. So that means given any off range of functions and we wish to extend to the full range, and we have two options. One is I can extend in the full range. One is an odd periodic extension, odd periodic extension. The other one is even periodic extension. So in even, periodic extension. So the other name for this are, so when I say odd function, so it contains in the Fourier series, if this is a full range Fourier series, that is what is we have defined f of x is equal to a naught by 2 plus summation n running from 1 to infinity a n cos 2 n pi x by t plus summation n running from 1 to infinity bn sin 2 n pi x by t. So this is full range Fourier series. Full range Fourier series. Okay. So now we have discussing half range. So when you say it is a half range, either it contains the sine terms or it contains the cosine terms. Okay. So now sine terms, when it contains sine terms, so that will be we also called as odd periodic extension. So that is f of x is equal to summation n running from 1 to infinity bn into, so bn into sine Now when I say it is odd periodic extension, so that means in the example I have taken 0 to 2, this is a half range and I am extending this with the full range. The full range is, now it is full range. Okay, so now here when you take full range we have 2. When you take half range, it should not contain 2. So that means sine n pi x by t. Got it? So what is the difference between half range and full range? Similarly, for even periodic extension, this is called as half range sine series. The definition. Half range sine series. Similarly, again, if I say this is even periodic extension, that means it contains only the cosine terms. So therefore f of x is a naught by 2 plus summation n running from 1 to infinity a n cos. So now in the full range it contains 2. So now in the half range it should not contain 2. That is cos n pi x by t. So this is we called as half range cosine series. Half range cosine series. So now this is taken an example. Okay, in general, suppose any function in the graph, I'll explain through the graph. Any function is defined in the interval 0 to t. So this is we called as half range, not a full range. Any function f of x, it is defined such that x belongs to 0 comma t. Okay, so in that function, so it can be any functions. It can be a piecewise or it can be a continuous function. So anything it can be in the range 0 to t. Now I wish to extend this in the full range. So that means in the full range minus tt plus t is the full range. This is full range series. So now we have a chance of extending either an odd extension, that is it contains sine terms, or an even extension, it contains cosine terms. So if you wish to extend, because if you want to extend the given half range, given function with the half range cosine series, this means in other words, you are extending as a even periodic extension. You are doing the given function as an even function. You are converting the given function as an even function. Or if you are extending the given function with the half range sine series, it means you are extending the function as an odd function. So that's it. So the definition for half range. So now given any half range, so the function is defined in a half range only. So now we wish to do we expand with the full range. So just by considering only cosine terms or sine terms. So the definition is half range cosine series. I'll define first half range cosine series. Half range cosine series. So it contains only cos terms. So f of x equals a naught by 2 plus summation n running from 1 to infinity an cos n pi x by t, where a naught is defined 2 by t integration from 0 to t, because the interval is defined 0 to t only, 0 to t f of x into dx. Similarly, an is 2 by t integration from 0 to t f of x into cos n pi x by t into dx. So this is half range cosine series definition. So now we can define half range sine series. So that is half range sine series. So it contains only sine terms. F of x equals summation n running from 1 to infinity bn sine n pi x by t. So where bn is 2 by t integration from 0 to t f of x into sine n pi x by t into dx. So this is the definition of half range sine series. Okay, so please note a definition. Half range sine series. So the intention is either you can extend given function in an half range to the full range, either as an odd function or an even function. So in other words, when I say odd function means half range sine series, even function means half range cosine series. So given in any signal, electrical signal or radar, any signal, suppose you want to analyze in if it is given in half range, so you can convert into the full range and you can easily analyze. So this is another application part of half range series. So please note this definition. So I'll share the notes. The same thing is given. The notes is itself. So here, if a function is defined over a half range, say 0 to t, instead of full range minus t to t, it may be extended in a series of sine terms only or cosine terms only. The series produced is then called half-range Fourier series. So the definition of half-range sine series is some f of x is equal to summation n running from 1 to infinity bn sine n pi x by t, where bn is 2 by t integration from 0 to t f of x sine n pi x by t dx. Similarly, definition for half-range cosine series, it is f of x equals a naught by 2 plus summation n running from 1 to infinity an cos n pi x by t, where a naught is 2 by t integration from 0 to t f of x into dx, and similarly an is 2 by t integration from 0 to t f of x into cos n pi x by t into dx. So it's a simple definition. So difference between full range and half range is, in the full range the interval is given always say minus t to t, and in the if it is defined in as a half range 0 to t, then the same Fourier series represented with a slight modification. So the modification is, in the series we have contains all the three terms, that is cosine terms, sine terms and a naught by 2 constant term, whereas in half range it contains either cosine terms or sine terms. So now we take an example, express f of x.
Excuse me, sir.
Yes.
Sorry to interrupt. So basically, how would you differentiate between half range and full range?
According to the
this one, no, sir. The value of.
Okay, suppose if I say a function f of x plus t is equal to f of x, so it is a periodic function with period t. Okay, so the definition is like this. So, and if I am not specifying a function f of x plus t is equal to f of x, so this t is a full range period. Actually, the t, it is full period of a full range function. Okay, so now if I'm not saying this f of x plus t is equal to f of x, and that indicates only is I should specify, express the function f of x in terms of either cosine, half range cosine or sine series. So I should, otherwise the function is defined say 0 less than x less than t. Suppose the f of x is defined in the interval 0 to t, and it is not specifying. It can specify either. So in this way, f of x plus 2t is equal to f of x. So this is also the indication of recognizing that the given function is a given function within half range period, so not a full range period. So this is one indication. Or else f of other than this, if it, suppose what happens if you take the full range series and you are extending suppose say given a function f of x is as a full range series, so 0 to t, assuming that f of x plus t is equal to f of x, it's a periodic function and it is defined f of x any function, so in the interval 0 to t, and you are applying for this period t and for a half range series, and you are assuming that it is an half range, and you wish to extend with either cosine or sine terms. So then what then the series looks takes 2 times that period, and it will shrink that whatever what is actual signal will be shrinking. So there will be more noises in that function. That's clear. Unless it is specified, so what I mean, unless it is specified, you can use, I mean, you can extend the function, given periodic function with the odd extension or periodic, unless it is specified. If you do, it will, the period will be shrink. So if you notice that the given function is either in this form or in this form, then you can easily apply the required Fourier series. Okay. So,
Sir, understood.
okay, now we take another example. So f of x, I have taken same example. F of x is equal to x defined in the interval 0 less than x less than pi, I think, sorry, less than 2 as half range sine series. Express f of x. So I'll take this example. Express f of x is equal to x as a half range sine series in the interval 0 less than x less than 2. So the same example, 0 less than x less than 2. For half range sine series. So we need to express half range sine series. So that is, here this function f of x is defined x such that x belongs to 0 comma t. So in general we have defined half range sine series for this type of function. So now the definition for half range sine series is half range sine series. The definition is f of x equals summation n running from 1 to infinity bn sine n pi x by t. So I have specified why 2 is not here in the half range. So because it is not, period is now off, so called as equation 1, and bn is defined as 2 by t integration from 0 to t f of x into sine n pi x by t into dx. So with this definition, given function, so f of x is equal to x is given, and 0 to t. So here t is 2. Okay, so this is the t, and with that I can easily compute bn. So therefore bn equals 2 by 2 integration from 0 to 2, 0 to 2 f of x is x into sine n pi x by 2 into dx. So that becomes 2 to cancel, so you'll get 1. So that is first function x into integration of sine is minus cos n pi x by t divided by, sorry, what is t? T is 2 divided by n pi by 2, then minus derivative of x is 1 into integration of cos minus integration of cos
Excuse
is,
me, sir.
yes,
Sir, I have a doubt.
okay,
Sir, will it be given every time it's sine extension or cosine extension?
sorry, pardon,
Will it be given every time it is sine or cosine?
yeah, and it is not, every time is not sine, it is not, if it is given every time, So you have to find sine series, half range. That means, okay, let me explain. So here in this example, see this function, let me write a graph of this function, the same we have taken in the previous example. So this function is the original graph of this function in the interval 0 to 2 is a straight line passing through origin. Okay, so this is say 2. And now, so I am asking you to find half range sine series. So that means you have to consider a full range, say -2 to 2 with the 0 origin as a midpoint. And so when you're using a sine series, the function sine is an odd function. And you have, in other words, geometrically you are extending this function with an odd periodic extension. So you just continue this with the same straight line with up to -2 in the domain range, and so the domain will be -2 to 2. So this now this function, whatever 0 to 2, now extending in the interval -2 to 2, you get again a straight line. And if you see, this is an odd function throughout in the interval -2 to 2, it looks like an odd function. So now if I specify it as a sine, and if I can also, the same function, same interval, I can also ask you to find cosine, half range cosine series. So in that case, so we will consider in the interval, full interval -2 to 2, so the function looks like an even function. So this is for if you wish to extend with the cosine terms, the graph will looks like this. And if you wish to extend with the sine, half range sine, and this is, the graph will looks like in the interval -2 to 2, like this.
Excuse me, sir.
Yes.
Sir,
Pardon?
can you hear me?
Sorry? Any doubt?
Sir, your voice is breaking.
My voice? Is it
Yes, sir, can
breaking?
you hear me?
You are not able to hear
Yes,
my
sir.
voice?
Now I can, sir. Sir,
Should
I
I
guess
speak loud?
so we can hear. I can hear you now.
Sorry, I didn't get you.
Can you hear me, sir?
Can you speak loudly?
Sir, can you hear me?
Sorry.
Sir, now?
Yeah, you can ask, man. You whatever your doubts.
So,
Sorry.
so I guess basically she meant to ask that will it be given in the question that is it sine extension or cosine extension? Will it be specified in the question?
Yeah, in the question, if you're talking about a question, it will be definitely they will specify in the question. So like what I just given a question, right? X plus f of x is equal to x as a half range sine series. So this is the question. In the question itself they specify.
Okay.
So what I am talking, what I explained in the graph is, you can, if it is forget about the question, whatever given function, you whatever your wish, if you wish to explain this in the full range, say sine series, if you're using sine series, then this looks like a odd extension, odd periodic extension. Or else the same function, if you use sine cosine series, it will looks like a even periodic extension. That's it. I mean, what actually, if you're talking about in the question, definitely they will specify the question, express given function with the half range sine series or half range cosine series. They'll definitely specify. Is it clear?
Yes, sir. Yes, sir. Understood.
Thank you. So now
She didn't no to ask.
Okay. I'm sorry, actually, because of I am not hearing, so now I increase my volume. Now it's clear. So now,
Sir, excuse me, sir.
yes, please.
So here in this half range questions is T like full period or half period, sir?
It is half period. The question they specified is a half period only. 0 to T, that is 2 is the T. So
Here
in
it
the,
is half
yeah,
period, sir.
yeah.
But in the other regular Fourier series, T is full period.
Yeah. So when you see, that is the what I explained here. When if the period is if the function in this, if you see in this one, in the full range, the function they specify f of x plus t is equal to f of x. This particularly specify this. So and ask you to find Fourier series. So this t is the period, that is full period. The range of x is, that is, I mean, it can be anything, c to c plus t actually. So now if you say c, I mean the period is t, and if you compute its difference will be again t only. Is it clear? So that in the Fourier full range Fourier series, that period was full period. Now in the half range, the period is we have taken, actually we are not deriving this series. What will happen in the, if I derive, you can easily also get what is happen half range series. So the intention is the same. You wish to extend either a cosine series, or you can extend with the sine series. Whereas in the full range, if this interval defined in a minus t to t, suppose if this in the full range, if the function x defined say minus t to t, then I can check whether f of x is even or odd. Even or odd, this I can easily check here. Okay, I think if you remember, we have done this for even piecewise function also, and even for a continuous function also. We have taken, for example, mod x in the interval minus pi to pi, if you remember. Okay, so in this case I can check even or odd. If it is even, again I can say it can, because why it is only contains cosine terms if it is even. The simple derivation is that if you see an definition, what is the an definition? Actually in the full range it's same, 2 by t integration from c to c plus t f of x into cos n pi, sorry, 2n pi x by t into dx. Okay, so now the interval of x is minus t to plus t. Okay, so in that case, and our function f of x, say it is odd. If the function is odd, and cos is what? Cos term is cos of a function, cos of x is even. What is the product of odd into even? Is odd. What is the integration of an odd function in the interval minus t to t? Obviously it is 0. If you remember, we have given this definition. So basically this will be 0. So and only it contains bn, whereas bn 2 by t integration from minus t to t f of x into sine 2n pi x by t into dx. So here f of x is odd and sine is odd. So odd into odd, the integrand becomes even. So then this result will be some 2 by t into 2 times 0 to t I can write, and f of x same integrand. So this will be, if it is an odd function, only bn gives you non-zero term, whereas a0 and an both gives you, even a0 is also gives you in the interval minus t to t if f of x is odd. What is if f of x is odd in the interval, odd function interval, integration of odd function is 0. So for an odd function, A naught and AN become 0, Bn is non-zero. Similarly, if it is even, suppose if it is even, so I think you have confused with this. If my guess is correct, there also we are using sine term and cosine term separately. Here it is defined. They are called as different notations. Actually, when it is defined in a full range Fourier series, this is the basic definition we are using. We make use of basic definition, and we are saying if the function is even, only it contains cosine terms. If the function is odd, it contains sine terms. The basic definition is this. Suppose this is even, okay, and cosine is always even, the resultant, their product will be again even. So then this the AN is non-zero, and this is similarly A naught. If it is even, obviously A naught is non-zero. Whereas come to this Bn, f of x is even and sine is odd, so their product is odd and their result will be 0. The integration of odd function is 0. So we call this only, so with this observation we can say if f of x is even, it contains only sine term. That in other words, I can get only A naught and AN. I'm getting Bn is 0. So this is the basic definition. From the basic definition, we called it was like if it is an even function, it contains only cosine term. If it is an odd function, it contains only sine terms. Please don't confuse with that definition and half range and full range, half range sine and odd functions. I hope now it is clear.
Yes, sir.
Okay, so basic we were using basic definition. Now it is given as a half period, some half range. It is given as a half range now. So in the half range, okay, in the half range, so here this period is, in the half range we define from 0 to t itself, not from the minus t to t or some c to c plus t. We have not defined this function. We have not defined. Please note, the x is not defined in the interval c to c plus t. It is defined only in the interval 0 to t. So I hope now it is clear. You can also distinguish this for a full range and half range. So now I have taken this example and we have did an integration, limits from 0 to 2. Now you put the limit from 0 to 2, so that becomes, when you put an upper limit, we get 2 times, so negative 2 times cos n pi, so n pi 2 divided by 2 whole divided by n pi by 2, and with the negative, since lower limit is 0, x is 0, whatever cos 0, it is 0. So here is minus into minus plus. So when you put an upper limit, we get sine n pi 2 by 2 divided by n pi by 2 whole square, and minus lower limit sine 0 is 0. So here 2 to get cancelled, sine n pi is also 0, and 2 to get cancelled, we get cos n pi, and with negative sign, so this is, so this 2 goes to numerator, minus 4 divided by n pi into cos n pi value is minus 1 power n. So this is Bn. So value of Bn is minus 4 divided by n pi into minus 1 power n. Okay. So any doubt? So I hope your calculation you can easily understand. Just you see the question. Since I am not writing complete question, maybe you have confused. So now you substitute this in equation 1. So equation 1 implies we get f of x. So f of x is x equals summation n running from 1 to infinity bn. So bn is minus 4 divided by n pi into minus 1 power n into sine n pi x by 2. So here it is t is 2. Sine n pi x by 2. So is the required half range cosine series. Sorry, not cosine. Half range sine series in the interval 0 to 2. So that means now the result is now extended to minus 2 to 2. So when you use this, it will get results in the interval minus 2 to 2 if you wish to plot. So the plotting and all those things we'll see in the MATLAB. So let me take the same example and I will extend with the half range of what is that sine series. So I'll write a example. Express f of x equals x in the half range cosine series with 0 less than x less than 2. 0 less than x less than 2. So here it is defined, we wish to express this given function in the half range cosine series. So the definition for half range cosine series is that we have f of x equals a naught by 2 in plus summation n running from 1 to infinity an cos n pi x by t, called as equation 1, where a naught is 2 by t integration from 0 to t f of x into dx, and an is 2 by t integration from 0 to t f of x into cos n pi x by t into dx. So with this function f of x, that is x, and defined in the interval 0 to 2. So here it is 2, t value is 2. So now using this f of x and t equal to 2, I can evaluate a naught and an. So that is a naught is 2 by 2 integration from 0 to 2 f of x is x into dx. So 2 to cancel, we get 1. So that is integration of x is x square by 2, limits from 0 to 2. After substituting limits, we get a naught value is 2. So that is 2 square is 4, 4 by 2 is 2. So that implies a naught value is 2. Now similarly, we need to find an. So that is an is 2 by t, so 2 by 2 integration from 0 to t, that is t is 2, x into cos n pi x by t, t is 2 into dx. So same again 2 to cancelled, we get 1. So now Leibniz rule or by parts rule we can apply. First function into integration of cos is sine n pi x by 2 whole divided by n pi by 2 minus derivative of x is 1 into integration of sine is minus cos n pi x by 2 whole divided by n pi by 2 into n pi by 2 becomes n pi by 2 whole square, limits from 0 to 2. So now when you put an upper limit and lower limit, so I can easily view that we get when you put an upper limit sin n pi 2 by 2, so that becomes sin n pi. So sin n pi value is 0. This is 0. And similarly lower limit sin 0 is also 0. So for both the upper limit and lower limit, the first term is 0. And now for the second term, so we get minus into minus plus, and can take it is n pi by 2 whole square, so 1 over n pi by 2 whole square, and put the upper limit, so we get cos n pi by 2 into 2, so x is 2, and minus lower limit cos 0, so that becomes, so it is 1 by 2 square is 4 divided by n pi whole square into minus 1 power n minus 1, cos 0 is 1. So this is an. Okay. So now I can substitute a0 and an in equation 1. Equation 1 implies that is x is equal to 2 by 2 is 1 plus summation n running from 1 to infinity, an is 4 by n pi whole square into minus 1 power n minus 1 into cos n pi x by 2 is the required. Now you see this value and that actually, so just go back to the full range Fourier series. So in the full range series, if you remember, if I ask you to obtain the Fourier series, if I ask you the same function, obtain a Fourier series called as fs for the function f of x equals x in the interval say minus 2 to 2. So now what you will do? What you will do? So you will check. You will think that this x is a odd function. So obviously you can say a0 and an will be 0. Both will be 0 since in this interval f of x is odd. So directly you will come to calculate bn. So this obviously non-zero. Anyhow, this is one way of doing. If I ask you obtain a Fourier series for this function in this interval. Now I'll change the interval. So what I mean, I'll ask you to the second part, or obtain a Fourier series for the function f of x equals x in the interval 0 less than x less than 2. So now what you will do in this interval 0 less than x less than 2? So this function is neither even nor odd. So obviously you have to find a0 and an. So you have to obtain what is a0, an and bn also. Look at the question and range. So both range, if you look at question and range, you can decide what we are doing. Okay, in the interval 0 to 2, if I ask you to find Fourier series, not an half-range series. So here it is full range Fourier series. Then doing this, so some terms maybe get 0, but I cannot say. Whereas the same question defined earlier in the interval -2 to 2. So now you have a question, you can easily test whether it is a even or odd, and based on that you can reduce the calculation of A0 and A, and directly you go BA. And now coming to this, what we have done, the examples, the same function, we have taken we have defined two different examples. One is express f of x is equal to x in the half-range sine series, and f of x is equal to x in the half-range cosine series. So that is based on the question also, you can answer the appropriately. Now I hope you are clear the doubts regarding the questions. Okay, so now I'll stop today's class at this stage. We'll take few more example in the next class. So any doubt you can ask me now, so we can easily share our discussions. So someone has texted a message. Okay, sir, can you please record the meeting? Yeah, I am recording this meeting. You can also download from your side. So I'm stop the recording, or else I will also share this, because I'll check with the capacity, the size of this video, and we'll do that. So just a minute, I'll take attendance. Okay, so thank you. If you have any doubt, we can discuss. It's time to discuss your issues. Issues in the sense it's related to the topic. Okay. Coming to the yesterday topic, I have, is there Muhammad? Okay. Yesterday, what you are saying, you cannot view calendar in your login. Or I talked with the person, so he said since they are guest to the teams, that means you are the guest to the teams, you cannot view or you cannot schedule any meeting for to the respect to the owners. So here it is two part, they are divided. Faculty members are make as a owner of the respective teams, and the students are the guests. So guests are not able to access the calendars, or they can, if I permitted, if I upload any notes or any study materials in your teams, so they can download. That option they are given, and you cannot view the calendar created by the owners in your logins. That is what they have said. So that's the reason. So what I plan, I will share the link of the classes before 15 minutes or possible 10 minutes or possible 30 minutes to start the classes. Okay. So this was what we have discussed previously, and if you have any other issues, we can talk to that respective here in the whatever by HOD's level, or that's all. I think Sohaib is not in the meeting. If it is there, please convey him. Thank you all.